Okay, so next I'm going to do the derivative of n of x. This is actually problem 3 on the set that I got. So my problem was 1 over the square root of 2x to the power 6 plus 8x. And I actually defined this function as f of g of h of x. And I know I could have made it f of g of x, or I could have not. There's different ways I could have done this one, but I made it f of g of h of x. So by that I mean my f of x was 1 over x. My g of x was the square root of x because everything in here is being taken the square root of. And then my h of x was everything that's being square rooted. So it's at 2x to the power 6 plus 8x. When I said that it could have been an f of g of x, I mean that I think I could have just done this, like the denominator as its own function. I don't think I needed to break it apart into the square root of x, but I tried that and it just seemed too complicated, so I gave up on it and I decided to make it 3 functions because you can do that, or at least I say you can. So now that I have my functions defined, in the actual composite function that I'm dealing with, I'm going to take their derivatives. So my f of x is that 1 over this x. So the derivative, you can solve for using the quotient rule. We've done it a couple times now, so I just kind of know. Because you do this 1 is 0 times 1, it's just this whole thing. So it just becomes -1 over x squared. And then that's the terms for f prime x and f of x. Then for g of x, which is the next term in the equation, you have the square root x. I always tend to make it like the exponents, just because it was easier in the beginning when using the power rule. So I can drop that down and make it 1/2 x to the -1/2. But then that's also equal to 1 over 2x to the 1/2. That's the proper way of writing it because you don't have the negative exponent. And then h of x is the terms inside. So that's these terms right here. So it's 2x to the power of 6 plus 8x. I can use the power rule here, which we've done a bunch of times, and I just did. So it's 12x to the power of 5, and then 8, because the x goes away, because it's x to the power of 0. So now, since I have 3 functions, I'm going to use that composite, that chain rule that I kind of discussed at the beginning, that I made from generalizing the problems we've done in the past with 3 composites. I'm not going to go over it because you can see it right here on my paper. So in order to do that, the first step I did was I did just the derivative of f of x, and then I put the non-derivatives of g and h of x inside of that. So it's f prime x g of h of x. So it's the derivative right here. That's the -1 and the squared, and then inside is that square root of 2x power of 6 plus 8x, which I've noticed that all you're changing from the original equation is you're changing this f to an f prime, which becomes super easy when you're rewriting it. And then you multiply that by g prime h of x. So my g prime is 1/2 x to the power of 1/2. I kept it in the proper form for writing it out, instead of making it like this. I don't know why, that's just what I did. So, and then inside for x, I have h of x, which is right here. So instead of writing just x, I plugged in h of x. And then I multiplied that by the derivative of h of x, which is 12x to the power of 5 plus 8. So I wrote that over 1 because I have 2 fractions right here. So what I'm going to want to do is put this on the numerator and then have these 2 multiplied by each other on the denominator, multiply right across. I always tend to do this when I have fractions. I probably did in the first problem. And all of these 3 terms are the derivative. Now I just have to simplify. So in simplifying, I have this -1 over this. Okay, so I have this square root squared. So my square root goes away because you're squaring a square root. What does that do? Nothing. It cancels out. So now I just have -1 over 2x to the power of 6 plus 8x. That's my simplified first problem. And then now here, I distributed this 2 to both the terms in here. So now I have 4x to the power of 6 plus 16x to the power of, oh, I put 1, just because I just did. Why not? And then this one I didn't change at all because it didn't need to be simplified any further. And now from here to like my final written answer, all I do is like multiply across. Like I just multiply these -1 times this, and then this times 1. And I put them in parentheses, so it's pretty clear. So my final answer is that negative, because we have that -1 times a positive. So it's negative 12x to the power of 5, 12x to the power of 5 plus 8. And then we have our 2x to the power of 6 plus 8 right here. And then, what I did was I ended up dropping my power inside, which I don't know if I needed to do, but I did just for like simplifying, I guess. So when you have exponents multiplied by exponents, you can just like, I don't know. Actually, I don't know why I did that. No, I didn't need to do that, so I'm just not going to. Actually, my answer is going to be 4x to the power of 6, and then, right, and then that's all to the 1/2. Because I don't think I needed to do that to simplify, and I'm not sure if that's actually correct when I did it. So this is my final answer. These two are just multiplied by each other as they should be in the formula, and then this is just, whatever. Anyways, that's the answer.